they still can learn this through my YouTube channel. So without further ado, we will start this lecture. Okay, I hope all of you can see this. Okay, can see my presentation. Okay, okay. Few people who just joined this lecture, I just want to say welcome. And first, we are going to start with our previous assignment. We will discuss, okay, little bit. Okay, okay. The uniform 10 kg rod AB is supported by a ball and socket at A. Okay, it's a ball and socket. And by the cord CG, cord CG that is attached to the midpoint of the cord G, as shown in figure 1. Okay, the rod is leans against a frictionless vertical wall at B. Okay, on the axis provided, draw a free body diagram of the rod. So the free body diagram of the rod. Okay, so please. Okay, so please be alert that the unit is in millimeter. Okay. Okay. So what we need to do is to convert a millimeter to the meter. Okay. So basically 150 okay. So here is 0.15. Okay. Then 0.15 as well. 0.4, 0.6. Okay. So from here, we write the coordinate of each position. For A, it is X, so which is 0.6. And then 0, 0. And then for C, will be 0. Then okay, Y is equal to 0.4. And then negative 0.15. For B, the position B will be X is 0, Y is 0.4, and Z is okay. For what else? G, C, okay, G, okay, G we need to calculate lah. Okay, so from here, first we draw the free body diagram. Okay, this is the rod, and then A, there will be 3 forces which is acted at AX, AY, and AZ. And then GC. Okay, GC. There will be a TGC. And then at B, there will be a normal forces, which is, I name it as Bn, Bn. Okay. So we rewrite all of the forces. It will be, okay, it will be okay for B will be equal to Bi, and then TGC equal to TGC GC over magnitude of GC. Then forces at A will be AXI plus AYJ plus AZK. Then not to forget the weight. Okay, W is equal to 10 times with 9.81, which is equal to 98.1 G. Okay. Okay. So from here, what we need to do next is, based on the moment in three-dimensional definition, we need to calculate the all of the unknown, which is AX, AY, AZ, and TGC. So using our understanding, we can determine TGC and BN by taking moment at A. So by taking moment at A, we can use RAG and RAB, okay, to determine the TGC and BN. So summation of moment at A will be equal to R, okay, RA, this point is G, A, and B. Okay, so RAG cross with TGC, okay, plus with okay, there's somebody just request to join the class, so let me approve for a while. Okay, then cross with W plus with RAB cross with B, which is force B. Okay, so for RAG, okay, to calculate the position vector of RAG, okay, what we know, the position vector of B and E, and then we know that based on the question, it informed G is the midpoint. Okay, midpoint. Okay. Since it is a midpoint, so we know RAG is equal to half of RAB. Okay. So 1/2 RAB. RAB will be B minus A. So from here, zero minus 0.6 I plus with so you will have equal to negative 0.6 divided with 2. So you will have negative 0.3 I plus 0.2 J plus with 0.75 betul ke? 0.15 divided by 2, 0.075 Okay. 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 So now we are able to wait where's my book? Okay. So next is we need to determine TGC TGC. Okay. TGC equal to TGC times with GC and magnitude of GC. So GC, okay, we already have the position vector of G, which is negative 0.3. Okay, this is the coordinate of G. Okay, did you guys get the same with me? Okay. Okay. So I assume all of you get the same with me. So TGC will be C minus with G. Okay. So from here, RGC equal to 0, okay, plus minus so it will be plus so TGC 0, okay, 0 minus 0.3, then I zero point 0.4 minus with 0, J plus with minus 0.15 minus 0 sorry. Okay. C minus with G. Okay, this is G, okay, C plus with 0.4 minus 0.2. Okay, this is J plus with minus 0.15 minus 0.75. So you will have 0.3 I plus 0.2 J and then minus 0.225.
Sir,
Yes.
can I know why for the K it was negative 0.15 minus 0.75? Isn't it 0.075?
Okay, 0.075. Okay, negative 0.55 K minus with 0.075 plus this is J plus with negative. Okay. So now what else? We can begin our moment calculation. So RAG, okay, this is I, J, and K. Okay, RAG okay, will be negative 0.3, 0.2, and 0.075. And then for TGC, okay, okay, TGC, okay, TGC, this one will be 0.3 I plus so you have a value of 0.425. 0.425. So TGC over 0.425. No need to divide this part yet. okay, and then IJK, and then TGC, RAG times with TGC. So for TGC, you put it outside, okay. TGC over 0.425, okay. Then for this part is I, J, and K, okay. Then RAG 2 and 0.075. Then TGC, okay, 0.3, 0.2, negative 0.225. Then plus with RAG cross with W, okay, RAG cross with W, I, J, and K. Then W will be, okay, Y, Y will be 0, and then it's going downward, so it will be negative 0. RAB, then RAB here times with FB, FB, FB. Force B, which is only I, so it will be B, okay, B, put it B over there, and 0, 0. Okay, so next will be, okay, I will show you this part, so TGC over 0.425, okay, I 0.2 times with negative 0.225 minus with 0.75 times with 0.2, okay, okay. Then this is for J. Then for K, K plus V, okay. This is for the first part, and then plus with, okay, this part, okay, I will make it blue, so that to avoid any confusion. Okay, this one is for I.
Sir,
Uh-huh.
for the TGC, we need calculate the value J.
Yeah, okay. J negative 0.3 times with negative 0. Okay, I did not include the J. So now I will include J. For J, negative 0.3 times with negative 0.225 minus with this is J. Then for K, okay, for J, always remember this negative. Okay. K, okay, for J, for G, okay. Mm-hmm. 0.3 is for K. Okay. So for the last one, plus with this one, uh, okay, now you solve all these numbers, all these value, in I, J, and K. Okay. Okay, did you calculate? Okay. For TGC, make sure after you finish calculate all this part. Okay, for I, J, and K, and then times with TGC over 0.425. Okay, for this part, what did you get? Okay. Hello, anybody? What did you get for this part? TGC over 0.425. So you will have negative 0.06 I with negative 0.06 minus with Okay. Plus with 0.2925 J. Okay. And negative 0.2 1 to K K. Okay. This 0. And then this one also 0. Okay. Okay, then for this, for the blue part, negative or positive
So,
Yes.
for the TGC, the J value is negative 0.045, right?
0.
0.045.
Negative 0.045 Okay, and then for the blue one, can you please tell me what is the results?
I haven't do yet.
Okay, let's do together 0.075 times 98.1 7 point okay. So I think no need for me to calculate. Okay, after this, once you have this kind of uh this kind of equation, so you will have I, J, and K. So what you need to do it after this is equate. Okay, equate in I, J, and K. Okay, and then get the value for why my mouse suddenly disappear. Oh my. Wait I have some technical problem. Kena tukar meter Kak Erin. So now equate in I, J, and K. So you will have I equation, J equation, and K equation. Okay. So get the value for TGC and B. Okay. And then substitute the value. Okay. Next is substitute the value of TGC and B in this equation, in all of the forces equation. So in all forces equation, okay, and then after that equate in summation of fx, summation of fy, and summation of fz. So you will have the answer for ax, ay, and ez. Okay. Okay. You can proceed with the, once you finish this assignment, you can proceed and submit to me.
Sir,
Yes.
if I know convert millimeter to meter, but the final answer, the value is same, can be accepted.
Yeah. You did not convert, but the value is still the same.
Yeah.
Oh, okay. So it's considered correct lah. Okay. But I'm not sure why, because it supposedly it must be converted to meter.
Okay.
Okay. Sekejap saya punya mouse ni cursor dia hilang. Okay, sekarang baru ada balik. Okay. Okay. Who asking me just now? Can you please switch on your microphone and tell me what is the answer for TGC? Okay, before I proceed to the next for the new chapter.
The TGC value is 52.12.
Sorry again, TGC
52.12.
52.12 Newton. And then for B?
I'm not sure the value is correct.
It's okay, it's okay.
73.5.
Okay. 733.5. And then for AX, AY, and AZ?
Negative 36.71.
Negative 36.7. And then AY?
73.57.
Newton. Okay. And then for AZ?
27.59.
7.59. Okay.
Sir,
Yeah.
What if I get for TGC 51.9?
Okay. Okay, is acceptable
Okay.
Okay, acceptable Is the answer is 52. Okay, but 51.9 also acceptable It's plus minus. Okay.
Okay, okay. Thank you, thank you.
Okay, alright. Okay, jawapan tu semua betul okay, just now the answer is TGC equal to 52.12, 73.5. For B, AX is negative 36.71, AY is 73.57, and then AZ is 27.6. Okay, this answer is correct I hope you can understand my explanation just now how I calculate and how I use IJK and then I substitute the value of TGC and B into the all of the summation of forces So finally you will get the value of AX, AY and AZ So okay, so you can submit the assignment. Now I will move to the next chapter, which is structural analysis sorry, alamak sikit lagi tekan. So move on to this part. Okay. Can you see the presentation, the PowerPoint, the PDF slide? Okay. So the objective of this lecture is basically to show how to determine the forces in the members of a truss, okay, using the method of joint and the method of section. And then to analyze the forces acting on the members of the structural analysis composed by the pin and then roller, okay. And then you are going to use some part of your knowledge in equilibrium of a rigid body in this chapter because you are still going to use the summation of all of the forces in x direction, and you also need to use to calculate moment in order to determine the support reaction forces, but the analysis is towards a trusses So the trusses is basically a combination of a truss, okay, and then this truss will okay, normally a bridge will have this kind of structure and then at each trusses will have their own forces which is acted in compression or tension So how do we know the forces is in compression or tension? Okay, it is by assuming okay, Okay, I will show you. Mm. Okay, for a compression, okay, for a compression, I want you to imagine that you are compressing, for example, you are compressing this calculator. So when you compress this calculator, the force will acted downward, okay, downward, and it is towards the body, okay. So let's say this is the truss, okay. So the force is actually compressed to the truss, but this is only for imagination, and then for tension, okay, this is truss, okay, truss or a body, if tension is acted to this truss or body, then it will be, okay, dia akan meregang, okay. So it just like you are pulling the truss or the body. So the forces will be leaving the body, so we can say in that way. Okay. Now, you have a few types of analysis that you can use in order to determine the forces at each of the trusses. Okay. For example, for this first example, I will show you this first example. Okay, determine the force. Okay, the force in each member of the truss and indicate whether the members are in tension or compression. So we need to determine the forces at FBC, FCA, and FAB. And we also need to determine either the force is acted in compression or in tension. Okay, some tips in order to calculate all the forces is that, okay, first you need to draw the free body diagram, the overall free body diagram. So now for A, we know it is a pin, so it will have AY and AX. And then C, which is a roller, so it will have normal forces. And then you have 500 Newton, which is acted to the right, okay, at B. Okay. Then, in order for us to start our calculation, this is the tips. You need to solve the part that have less than 2 unknown. Okay, for if we want to start our calculation at A, we cannot do it. Why? Because basically it have a force of FAC and then FAB. And then for C, we also cannot start any calculation at this point because it consists of FCN, FAC, and let's say FCB. Okay. So it have more than 2 unknown. Meanwhile, for B, okay, we have 500 Newton. Okay, and then we also have a force of FCB and FAB. So it only have two unknowns. So by knowing this, we know that we can solve the unknown starting from the joint B. So before that, we need to determine the angle at B. So sudut CBA equal to 180 degree minus 45 degree minus with 90 degree. So you will get a 45 degree. Then okay, now we have the angle here, which is 45 degree. Start our calculation at joint B. Okay, the free body diagram at B will be, okay, the force is leaving 500 Newton. Okay, this is the external forces. And then we also have F. Okay, here I will denote it as FBC. Okay, for your information, FBC is equal to FCB. Don't worry, this is just the same. And then I also assume that the forces is in tension as well at FBA. FBA. Okay, from here we can write an equation of equilibrium of a rigid body, which is positive, right? Summation of fx equal to 0. So here is 500. Okay, 500 minus with FBC. Okay, here. Okay, here and here is almost the same lah. So I take cos 45 degree. Okay, FBC is to the right, equal to 0. So FBC cos 45 degree so you will have the answer of equal to
Sir,
yes.
so why force Cn at x upward?
Why upward? Okay, it's just assumption. You know, you can assume the direction either upward or downward. Okay, if your assumption is I don't want to say wrong, it's not wrong. If your assumption is maybe in the opposite direction, so your answer will be negative. Okay, and then by changing the direction according to your answer, okay, so you will have the correct direction of the CN. Okay, so if you get negative, say don't worry, it's not wrong. Okay, it's just the answer is in the opposite direction. Okay, the answer and the direction is in the opposite direction. Okay, I will show you in this calculation. Okay, so now you have FBC equal to negative 707.11. Okay, so now continue with the y direction. Y equal to 0. So we have negative FBA Okay, before that, since our answer is negative, it is actually opposite to our assumption. Previously, I assumed it as a tension. Okay, so since it is not, since my answer is negative, so I write it again, 707.1 Newton. Okay, this is based on my assumption tension, but actually it is in compression. Why? Because the negative tell me that the opposite direction, the answer is in the opposite direction. Okay, so now I have in compression. Okay, so for the y direction, we need to correct our direction, which is not a compression, which is not a tension. Okay, it is basically a compression. Okay. Okay, so now I have negative FBA. Then I will take this part. Okay, FBC minus FBC cos 45 equal to 0. Okay, negative FBA minus 707.1 cos 45 degree equal to 0. So FBA is equal to 707.1 cos 45 degree. This is negative. Okay. Oh, this is positive sorry. Positive sebab dia ke atas Okay, 707 cos 45 degree. Okay, I will do it from the beginning Okay, since our results is in opposite direction to our early assumption, so we know that the forces is a compression. Now, F negative FBA plus with FBC cos 45 degree equal to 0. Negative FBA equal to negative FBC. Okay, you have a 500 Newton. Okay, now look back at your assumption. Since your assumption is net tension, and then you have a positive value, okay, so meaning that your assumption is correct. So it is in a tension. Okay, so what I usually do, I will write at the free body diagram that this part is a tension. Okay, so that I will not confuse and then this one will be a FCB is compression. Okay. Okay, now I already have the value of FB. What next is I will do at joint C okay, at joint C. At joint C, okay, draw again the free body diagram. Okay, C. Okay, C. I know there's a forces acting upward, which is Cn. And then I know as well there's a compression forces, okay, acting here. Okay, compression. So compression, and then I also know that there is another forces which is from C to A. Okay, I assume it as a tension. So FCA, then FBC. Okay. Okay, so now we write an equilibrium equation. X equal to 0. So FBC again cos 45 degree. Okay, there's somebody would like to join this class, so I will approve. Then FBC cos 45 degree minus, okay, not minus, is okay, it's moving to the left, so minus FCA. Okay, what else? That's all, So FCA is equal to FBC cos, which is equal to 707.1 cos 45. 500 Newton. Okay, we already have FCA. So now is to determine the upward forces, which is Fy equal to 0. So we have a Cn, then FBC, FBC cos 45 degree. Okay, basically I take this one for X direction, and then I take this one for Y direction. So both will show similar answer. FBC cos 45 degree. Okay. What else? Cn, FBC. Okay, that's all. Equal to 0. So Cn will be equal to again FBC is 707. So you also have a 500 Newton. So basically Cn is correct. The forces is going upward. And then for FCA, it is in tension. So we know here, we can write it again at we can include more information to our free body diagram. This is also in tension. Okay, and then we need to determine the support reaction forces. Okay, for support reaction forces at joint A. Okay. At joint A, we know that, okay, I assume A, this is AX, and then AY, and then this is, okay, BA is a tension. So tension is going upward. Okay. Then FAC is a tension as well. So it's going to the right. Okay, now a summation of we need to write a summation of equilibrium equation fx equal to 0. So ax will be okay. First ax plus with FAC FAC. Okay. FAC which is 500 equal to 0. AX is equal to negative 500 Newton. Okay. So now this one, since okay, like your friend asked just now, what if why I assume the direction of the forces to the for this part is to the right lah. I just assume it to the right. But actually, based on my calculation, it indicates that my assumption is in the supposedly to be in the opposite direction. So 500 Newton is to the left. Okay, to the left. Okay, so correct it according to your calculation, okay, not based on your assumption. Okay, so you have 500 Newton to the left. Okay. And then for AX, for AY, summation of all forces equal to 0. So you have a okay extension which is FBA. FBA is 500 Newton. 500 Newton plus with AY equal to 0. So AY is equal to negative 500 Newton. So basically AY is going to downward. Is going downward. Okay. So just little bit tips on how you are able to check either your answer is right or wrong. Okay. You must make sure that all of the joint will be equal to 0. Okay. Why it is equal to 0? Okay. Because the summation of all of the forces must be equal to 0. If your answer is not 0, then first is that your bridge design will destroy or break up or whatever. Okay, then it will show that your calculation is wrong. Okay, if you get value which is equal higher than 0. Okay, so you need to get must be equal to 0. Okay, let's take 5 before I proceed to the next example. Okay. Can you understand? You can ask me if you have anything inside your mind. Minum dulu Okay, Faris Iqmal, saya rasa saya dah menjawab soalan tadi why we use cos or why I use sin, because basically you can calculate at both sides either you want to use at the another side of angle or you want to use in the another side of angle. So that's why I'm using cos. Okay. Okay, so now I will proceed to the next example. Okay, but I want you to calculate on your own. Okay, try to solve this question. Okay, I will give you around 15 minutes. Okay, before you begin your calculation, so we know that here is a roller. So roller, it will have a normal force, and then here is a pin. So you will have Cx and Cy. Okay, and then you can solve okay, I think if you can solve some part of the okay by taking the equilibrium of equilibrium. Okay, so taking all the equilibrium using the equilibrium ni, so summation of fx equal to 0. You do it for all of the forces. Okay, and then summation of fy. Okay, so you will have a value of an. Okay, and then take the moment at c. Okay, then you will be able to determine for an. Okay. Oh, there's another forces here. 600 Newton. 600 Newton. Okay. Go to 0. Fx equal to 0. Then negative Cx plus 600 equal to 0. So Cx is equal to 600 Newton. Okay. Okay, this is, we call it as a global equilibrium. Okay. You apply global equilibrium to all of these forces. And then upward summation of fx equal to 0. Then you will have okay, but before you calculate summation in y-axis, you need to determine normal forces at A. So how you determine normal forces at A? You can use moment at C. Moment at C. Okay. So you will get the value of an. Okay. And then after you finish, after you calculate the AN, what's next is to apply the global equilibrium in y-axis, okay, in order to determine the value of Cy. Okay, try to solve it. Okay. Sekejap saya ada kena buat call kejap. Hello, Assalamualaikum. Sibuk ke? Oh ya ke? Sorry lah ganggu cuci ni. Kawin nak tanya sikit ni. Sebenarnya kalau nanti kan student postgrad, dia semua akan attach kepada IPS kan? Semuanya kejuruteraan kan? Bukan, maksudnya tak kira lah student tu register dekat FTKMA ke, FTKBM ke, dia akan directly berada di bawah satu institusi baru kan? Betul tak? Betul. Tapi ikutlah budak tu nak daftar FTKMA ke, nak lecturer tu FTKMA ke, lecturer FTKBM ke, ikut. Lepas tu jadi maksudnya tak ada masalah lah kan, kalau katakanlah student tu dia daripada mekatronik, kemudian dia nak buat proposal defense, lepas tu dia nak pindah ke FTKMA, boleh? Supervisor dia lecturer dekat mekatronik lah, katakanlah. Kejuruteraan, yeah. Maksudnya kejuruteraan dan Center of Excellence lah kan. Dia buat gitulah kan. Okay, faham. Cuba satu lagi, kalau dia dah lepas proposal ni kan. Betul, bila dia pindah ke tempat baru tu kan, dia proposal defense tu tak payah buat lah kan. Tak perlu. Terang. So dia dah centralize lah kan. Okay, beres bos. Beres. Terima kasih banyak, busy. Enjoy cuti. Okay. Betul lah, kena beli kereta baru lah kot. Tengok lain dengan betul. Beres. Geng. Terima kasih lah busy Assalamualaikum. Hello. Hi. Okay. Okay, so now I assume that you already calculate the value of all of the support reaction. So you should get a value of Cx equal to 600 Newton. Okay, 600 Newton, and then Cy equal to 200 Newton and then An okay, will be equal to 600 Newton. Okay. So you can calculate this using moment for AN, and then CY and CX. Okay, like I said previously, you are using a global equilibrium. Okay, now you have the information for CY and CX. Okay. And AN. Okay. So okay, based on my tips previously, you can begin the method of join, okay, from the okay, if you have more less than two unknown, okay. For example, here here you have FAB, and FAD, okay, and then which is, you know lah, you can start your calculation at this part. Okay, what about the other part of join? For B, you will have three unknown, 1, 2, and 3. And then for C, maybe you can start here and here. You still have two unknown, okay. And then for D, you will have three unknown, okay. You can start at C or at E, but I choose to begin at A. Okay, to begin at A, okay. Okay. You know that here is 4, and then this is 3, and then this is 5. So automatically you can use this, okay, to replace the angle. Okay, for FAD, draw the free body diagram. Okay. Okay, this is the free body diagram. Now apply the summation of forces equal to 0. So we have FAD minus with plus with FAB. Okay. 3/5 okay, equal to 0. Okay. Then we have Y, summation of all forces in Y axis. So AN equal to 600. Okay. And then plus with FAB equal to 0. So FAB will be equal to negative 600 Newton. Okay. Now this is based on my assumption that the forces is in tension. But actually supposedly FAB ni ada ada sudut ni. Okay. Okay. So basically it is in compression compression okay. Yes.
So,
Uh-huh.
for the FAB, the should multiply with 4/5.
Okay, I just mistakenly did not include 4/5 okay. Okay, you must include 4/5, eh? So 4/5. Okay, 4/5. Okay, equal to 0, eh? Okay, you will get 750, eh? Newton. Okay, and then not convert, you know that the direction of the forces supposedly in compression, eh? So now, draw back your forces. So instead of the forces in a tension, it is actually in a compression. Okay. So now you substitute FAB in the FAD. Eh? So you cannot use this equation anymore. Okay. You write the new equation based on the new assumption, based on the calculation that you get. So this is FAB. This is FAD. Then this is AN. FAB to the left. So FAD FAB 750 times with 3 divided by 5 equal to 450. Okay, so this is based on our assumption, which is tension. Okay, so now we know here is compression. Then here is FAD is in a tension. Okay. Okay, now next I will start from D. Start from D at D. Okay. Okay, you also have these forces. Okay, FDC, then FDB, then FDC. Okay, FDA. Okay, you have FDA and you need to find FDB and FDC. Okay, now I want you to try to create the equation for FDC and FDB. Okay. Okay, so basically, FDC will be is actually is a compression. Okay, so now we have FCD, we have okay, we need FBC. Okay, okay. Don't forget to write the okay. FDC is the compression. So don't forget to write this. Because it will be very helpful for you to imagine the forces, either it is going you towards the tension or towards the compression. So at joint B, basically a 400 Newton. Then FAB is a compression. Then C, I don't know yet, so I need to calculate FBC. Then I also know that FBD is a tension. Okay, so create the summation of forces. Okay, we already calculate the FAB equal to 750. Okay, and then FBC, and then FBD. FBD plus with FBD 250.
Sir,
Yes,
the force of FBD need to multiply of 3/5.
3/5. Okay. FBD. Okay, FBD. Okay, 250. FBD 250. Okay, 250. Times with right to the right will be 3/5. Okay. Okay, equal to 600. FBC negative 600 Newton. 600 Newton is basically in compression. Okay. Okay, so now we have FBC, which is in compression. Now what? Okay, so how do you know that your assumption is right or wrong? Again, C will be okay, CX and CY is mean okay. Okay. CX previously in to the left. Okay, by using at joint C, okay, it's going to the left. And then for C is going to the right. Okay. So 600 minus 600 equal to 0. So, and then for Y C FDC, okay, is in compression, okay, which is equal to 200 minus with 200 equal to 0. So you can conclude that your trusses is in equilibrium. Okay, that's finished for method of join. Okay, we will proceed to one more method, which is using method of section in order to calculate the forces at the trusses. Okay. Let's try this final example. Hundred, 1,200, then 3 meter. Okay. Okay. Basically, for method of section, okay, for method of section, instead of you calculate the trusses at part by part, so you can use a method of section directly in order to determine the forces at the trusses that you need to calculate. So for example, for GEBC, okay, you can use method of join, but you need to start somewhere at A or D, okay, and then you need to determine DE, DC, and the other part lah, until you arrive at EG, CG, and CB, okay. This is a very long method, okay, but by using the method of section, we just section this part, okay, section this part, then we assume that after the section, okay, the force will going either compression or in tension, okay. So after the section, we can apply the method of section analysis at this part, okay, that consists of this part, okay. This is if you choose the left hand side, okay. Let's say you choose the right hand side, so you only consider this part only, okay. Okay. Okay, so now based on the example, you need to calculate the force in members GE, GC, and BC. Okay, GE, GC, and BC. Okay. So, but before you determine the forces at GE, GC, and BC, you need to apply the global equilibrium. But don't forget as well to draw the free body diagram. Okay. It's 400 Newton, 1,200 Newton. Then this is normal, dn. Then A, Y, and AX. Okay. Okay, this is G, E, B, and C. Okay. Okay, in order for us to calculate GE, GC, and BC, we need to determine this support reaction. Okay. How can we determine the support reaction? Okay, for example, if you need to calculate, if you want to start your calculation at the right hand side, so you need to determine dn. Okay. In order to determine dn, you need to take the moment at A. Okay, which is equal to dn times with 12. Okay, it is in clockwise, so negative. Then clockwise as well. This is anti-clockwise. So let's say it's negative. Clockwise, negative. Times with 8 equal to 0. 1,200 Newton times 8 and then -1. Okay. 900 Newton. Okay, and then for AX and AY, you can apply the global equilibrium. Okay. So AY will be AY, then minus 1,200. Then the N will be plus 900. Okay. So now we have dn, ay, and ax. Okay. Okay. From here, you need to apply the method of section in order to determine force at members GE, GC, and BC. Okay, let's say I choose left hand side. So draw the free body diagram. Okay, this is after you cut through these trusses. So the forces will be FGE after the cutting of the section, and then it will be FGC and then FBC. Okay, so now, first, what we need to do is okay, I will take moment at FBC at moment G. So for method of section, you only consider this part only, the left hand side only. Okay. Moment at G. Okay. So you will have AX times with 4. Okay. Sorry, it must be 3 because it is perpendicular. So AX times with 3 is in anti-clockwise direction, so negative. Then let's say AY. Okay, AY is in up. Okay. Times with 4. In clockwise as well, eh? And then B, FBC times with 3. Okay. Plus equal to 0. Okay, FBC is basically, okay, since I assume it in tension, so my assumption is correct lah. Tension, 400 Newton. Okay. 300 Newton. The answer is, sorry, 1200 divided by 3. Hey. Oh, okay. Sorry, it's supposedly this is 1200 plus 1200, so 2400. So 2400 divided by 3 equal to 800 Newton. Okay, and then FBC. Okay, so now for FGE and FGC, you can use summation of X and Y direction. So this one is FGE plus with FGC times with 4 over okay, 4 over 5. Okay. Here, because this is 4 and then this is 3. So 4 over 5. Okay. Is going to the right. And then include as well your support reaction. So minus with AX 400 equal to 0. So this is the first equation. Then for y-axis go to 0. So minus FGC will be 3 over 5 FGC. Okay, because it's going downward. Then okay. Oh, okay, FBC. I did not include FBC. Okay, plus with FBC, 800. Okay. Then FGC, 3 over 5 going downward, plus AY, equal to 0. So 3/5 FGC equal to 300 So 300 times with 5 divided by 3 FGC equal to 500 Newton So okay, it is basically in tension Okay, FBC. Now FGE For FGE, substitute FGC in the first equation So 800 plus FGE plus with FGC 500 So you will get FGE plus 800 equal to 0. So FGE equal to negative 800 Newton So 800 Newton is basically in compression. Okay. Okay. So that's all for the class today. I will upload several quiz for you to answer. There will be 4 quiz that you need to do. Okay. And then that quiz you can do it in Kalam So before I end this class, if you have any question, you can ask to me Okay.
No, sir.
Ya. Ya, dengar. Hello? Hello? Kenapa tak ni Terputus ke? Saya tak dengar. Okay. So basically semalam ada dapat berita baru daripada kementerian yang universiti akan dibuka sepenuhnya lah. Tak silap saya bulan 10 ni. Jadi saya takut mungkin ada perubahan dari segi final tu mungkin entah tiba-tiba student kena hadir ke UMP ke untuk jawab final. So whatever it is sebelum apa-apa keputusan tu kamu just continue kamu punya study lah Okay, quiz akan ada dalam Kalam macam biasa So for moment, okay, quiz akan berdasarkan topik hari ni, kemudian moment dan beberapa topik-topik lain lah. Okay, untuk moment, okay, saya just nak tekankan sikit. Untuk moment, kamu mungkin memerlukan knowledge previous topik untuk final. For example, untuk calculate angle, okay, macam mana nak cari coordinate direction angle. Okay, benda-benda and then tarikh nanti ada dalam kalam Okay. Kemudian momen tu mungkin tak sekompleks yang saya bagi dalam example hari ni It will be much more straightforward, but you need to use your understanding in the previous chapter. Okay, for example, to calculate the angle, to calculate whatever you learned previously lah. Okay, that's all class for today. I will upload this lecture in the YouTube channel, and then for those who unable attend this online lecture, they can refer directly in my YouTube channel. Okay, thank you so much. Assalamualaikum and see you next week. Thank you. Thank you everyone.
Thank you, sir.